today, like I said, we're going to try something new. We're going to do a little more electronics. Perhaps in the future, maybe I'll get a full robotics kit and we'll just build it like each week in like maybe 6 parts. I don't know how long it'll take me to build and program a robot. Depends on which one we get. But today I'm just going to talk about one that I'm kind of currently working on. He's been sitting here for a while, so I don't know if I still consider working on him, but it's not done. So I'm going to talk about him a little bit, and then I'm just going to do like a basic kind of intro session to what electronics are. So if you've literally never touched any like electronic part, just kind of talk about like what it is, how it can be used, and I'm gonna do like a very simple circuit as well. Nothing too crazy, like super. It's probably like the most simple circuit that I can think of for us to build. So I don't want to do anything too crazy. And if I build anything complex, we'll be here literally all day, just watching me try to figure out why it's broken. So with that being said, I'm going to go ahead and switch to sharing my screen so you guys can see my workstation. So I would say I apologize for the mess, but I kind of don't, because a dirty desk is a sign of a very high mind, is what I'll say. A very intellectual mind gives you a dirty desk. So where do I start? So right now, this is my current robot that I'm working on. I think I have 2 of him. I don't remember where the second one is. The second one is with, I'll put him a little closer to the screen. The second one uses a Raspberry Pi. This one uses an Arduino. Basically, let me take it off so you can see. Because he has like this hat on top. You can see like right here. This whole top circuit piece is a hat so that I can make more connections. But if I take it off, basically. So this is the Arduino Uno. This is probably like the most introductory one people use. I hate this. Do it. This is Arduino Uno. It's when I tell people they want to get into robotics, I usually suggest them to do an Arduino because it's pretty easy to get into them, get started with them. They're not too expensive. I think they're like $30 each. You can also build them. I have this like proto board. This board here, and it's just blank. It has a few like connectors already put on it. Usually I get them without any of these connectors, so I can do whatever I want to it. And I usually get like a big one that I can like cut out the size pieces that I need. But I could use this and rebuild that Arduino over there if I wanted to, which I actually plan to, which is why I have this. That way I don't have to keep buying Arduinos, because I go through I don't know how many I've bought over time and have just vanished for some reason. So I was like, I'm gonna just make draw out online a circuit so that when I need a new one, I can just pull out some parts and just make my own. So basically, what an Arduino is, or any sort of microcontroller, this is a different Uno. It's by a different company, but it's the same. It's the same thing. Basically, what microcontrollers are the brains. It's the brain of the computer. So in robotics and in general with engineering, there's the hardware side of things, so like the mechanics. There's the electrical or the electronics, and then there's the software or the coding part of things. And you kind of need to know all of them. Some more than others, depending on what you're working on. Here is not as much mechanics because I'm not building like a body for this. Well, it has a body, kind of. Yes, these wheels. The wheels are missing, which is also partially why he's sitting here. There's a lot wrong with this guy. We'll get into that, and what he does and what he is. But so the mechanics is more like the bones of it. It's the skin. It's the structure. It's what holds it together. Literally, it feels the human body. Oh, and thank us for subscribing, Benny Cashman. Thank you. Welcome to the adventure. Welcome to the adventure. It's gonna be quite the ride. I don't think we're blowing anything up on robots today. Maybe we'll make like rockets in the future and go to space on my channel. I will try. I might actually do that. Now that I say it. Yeah. So the mechanics is the body. It's the framework. It's the structure, and like it's very necessary because otherwise you would be like this, just laying around everywhere. So in terms of like this robot, the mechanics would be more of these bolts along the side holding it, this base plate here. There's an ice cream truck outside. And the electrical is all of this stuff. So the wiring, the power systems, all of that, that's more of like the electrical parts of things. And then in the human body, that would be kind of like your nervous system. It's sending signals to and from so that everything can talk to everything else and controls everything. So that's what that is. And then the microcontroller here, this guy again, this is the brain. Basically, nothing is going to work without it. I mean, it might work. There are, you know, I would show you with a battery, but my current battery has this AC adapter on the end so that I can connect it to the board. The upside is I can just straight connect it to the board easily and just be like, you know, pop that bad boy in. We're all good. However, the downside to that is I can't really connect it straight to this. I'm very tempted to just grab some wire cutters, which I realize I don't have any right now. I'm tempted to grab some wire cutters and just snip it and just connect it, and it would work. But I think this is the only one I have with the AC adapter on the end, so I'm kind of not, I'm resisting doing that. Usually I have one that is already snipped off. I have a couple of different ones, but everything is everywhere. There's stuff everywhere. But for the most part, if you want to do robotics, you have to have some sort of brain. And it just makes sense. You have to program it to. I could put founder on my resume. Yeah, so without this, I could program this robot to like, I could get the wheels and put them directly to power and they will turn. But they're not going to know what to do. They're just going to go forever until they die, the battery dies. So with the microcontroller, I can send it signals, give it instructions, control speed, control movement, can really do whatever. Because at that point, you can use like, and they're usually pretty easy to program. I'm trying to see the goggles. I know I see the goggles on now. It's hard wearing two pairs of glasses. Even though I do have these like, what are they? I have these little things. These come in handy if you're like doing electronics or any sort of work and you need safety goggles, but you don't want to do this, which is, it works. And they do have glasses. I can do this, but I really personally don't like to wear two pairs of glasses at the same time. So instead I have these attachments that you can buy. I think I got like a pack of 5 for like $4 on Amazon. And you can put them on the edges of your glasses, and then that way they're up to safety standard. But if I'm at home, I probably won't use them unless I'm soldering. And if I'm soldering, I'm just gonna I'll just deal and wear these because I do not like the idea of potentially getting solder in my eyes. Never has happened. I don't see it like how it would happen. I don't trust it. So what I'm making, so right now we're mostly just kind of going over the different tools and parts that are here. But overall, and we're probably not going to work on this today. We might do this a different week because I have to do a lot of troubleshooting with this guy before I actually feel like bringing him out and finishing him. And he's missing a lot of parts, like he has no wheels. And the wiring is kind of funny, kind of funky to say the least back here because it needed to be soldered to look really focusing a camera is crazy. But these wires are separate. I soldered them together, and now looking at it, they're cut, and I don't know why they're cut. And I don't know what's going on with his power system is a hot mess right now. So, but basically what he does, just to go into what the purpose of this robot was. So I said he has an Arduino Uno on him, so he's very easy to program. Uno is based in C, which isn't the most friendly language, but they scaled it down to where it's just the necessities that you need. So it's a lot easier to get into, very simple instructions to give. And it has this hat on it that's controlling a motor driver. So this, under all of this cabling, way down there. So the red chip is a motor driver. Basically, what that does is on the Arduino Uno, you only have so much space on this without the hat, right? Let's take the hat off. So on here, you only have but so many connections along the sides, like here and somewhere up there. We only have so many connections. So in order to make more, one option is you could get a different chip. Like I know a lot of people when they do things that involve wheels, they get a Mega, which has extremely more connectors for it. But another way, which is the way of doing it, is I've got a hat on here and it expands the amount of things I can connect to it. Doesn't want to reattach. So you see up here we have like, so hard. There's a lot of things. It's kind of hard to see because my camera doesn't seem to want to focus. We'll work on that in the future. But there's a lot more connections on here for sensors. So motors, power, things like that. And then it connects to this motor driver on the side. And the motor driver, his little eyes. I love using those. So this motor driver makes it so that I can give the same instruction to multiple motors and they can kind of do the same thing. So I just ordered a cheap one. So I was trying to solder. Yeah, no, solder is not. I'm gonna show it what it is because I know some people are like very new to things. Like I said, we're just gonna go over. We're not so much gonna build too much to it. So we're gonna do like a really simple button LED circuit just to show like how things connect. But we're not gonna build or do anything. And we'll probably in the future. I have intentions of doing another show for specifically for Arduino. How to connect it, how to program it, things like that. So doing specifically on that, and then we'll also do a different one specifically on soldering and how to do it, because it is important and it's actually really useful. There have been times I've soldered things and I definitely should solder. I think there was once I needed a hole punched through something thick, and so I turned the heat all the way up and was poking holes through like cardboard using it. Don't do that. It's a fire hazard. And then there are times where, I soldered wires, but I think I soldered like my glasses once, not these ones, but a different pair. I soldered them back together. It's just useful. It's like welding, but it really is welding, but like extremely small scale, very delicate because you have to, you're putting it on like these itty bitty holes. And this is through hole soldering. Is easier because the alternative is, let's see if I have another circuit. This is all these on back here is all soldered. These are surface mounted. These are not surface mounted. These are surface mounted. All these little, it's hard to see them, but all these little parts that are like along the side, they're resistors, they're capacitors, they're LEDs, but they're just really small. And it's a good thing. Like that's how you get like smaller, more compact, but still high quality electronics is make the parts smaller. But in order for that to happen, you have to do soldering directly onto the surface, and it is very, very hard. I don't do much of that. I'm working on that myself because I need to learn it. But when I show how to solder, we'll probably just do through hole soldering, but I want to have my helping hands, which is a device that will hold it for you, because otherwise you need like 8 hands in order to do this. Imagine like Doc Ock, I think his name was, from Spider-Man. I'm probably saying his name wrong. Pretty sure. Someone correct me. But imagine like that's what you would need in order to solder without helping hands. You would need like 8 arms because you have to like hold the chip at the exact right angle and you have to keep it perfectly still while at the same time using like this soldering iron. I'm so all over the place today, but we're just gonna roll with it. I'd have no structure for this show right now. We're just talking about tech and robotics. But this is a soldering iron. I'm not turning it on because it gets really hot. Like I think this one goes to 450 degrees Celsius. So you can imagine how hot. I think if you turn it all the way up, the edge like glows red. I do not want to do that today. We're not going to do that today. It's very dangerous. So I want to make sure I have a plan in place when I'm doing that one, rather than just swinging it. So make some space here because things are getting crazy. I need like 3 toolboxes. But so the essentials, if you were to like wanting to get started yourself, the things that you would need off the jump, because you don't need all of this, but you need a lot of this. Just for a basic, I would buy a kit. So I have this one. I have a little one because my other one didn't have capacitors in it. And I'll talk about what those are. But I would get like a kit. So I got this super starter kit the other day. And there's a bajillion out there. Wink, wink for the future. I'm building one for you guys too, but that's coming later. But I bought this. Oh, it's too bright in here. There we go. Super starter kit. And inside, it came with just a bunch of stuff. I would say get something like this because these usually cover your bases in terms of like the basics. The important thing you need though is like just a controller, and probably a breadboard, most likely, because you're probably not going to start. I mean, you can start soldering things, but it's always best to have a breadboard. You have a bunch of holes in it that can't apparently be seen because it's so bright. But you need one of these because you want to make sure your circuit that you're designing works before you solder it. No one wants to desolder. This is a desoldering thing. You like push that down and then put it against whatever you're desoldering and like suck it out. It's very hard to use and I don't like to use it. I do it a different way with like the wick and it like heats up the solder. And you put this wick on it. Yeah, you put this wick on it and it soaks up the solder. It's a better way to do it, in my opinion. Yeah, so I would say do that. And then that way you can like just jump right into connecting it up to your computer. You can download Arduino for free, the software. And they have plenty of like tutorials and different projects you can do on there. But if you were to start, that's what I would say do, is get that kit. And it comes with like all of these came from that kit. So like you have this, which is just a display. So you can practice doing different visual effects on that. We have something else that's crazy. We have this switch. I have never used this type of switch before. I use more basic switches, but it just slides side to side. I have some buzzers, I think. So yeah, there's like buzzers in here. I think the other one has motors. We got 7-segment displays, which I will say 7 segments are a true testament to your patience. The very first time I did robotics, one of my projects was to program a 7-segment display to like cycle through every number. And it was, to say the least, difficult. But it's definitely fun. Like if you can program a 7-segment display, then you're well on your way to like getting stuff done. So let's see. I'm gonna go over really quickly before I keep ranting some parts and what they are, and then we'll go ahead and like put something together real quick. You know, see this LED turn on. That's ultimately what we're going to aim to do real quickly today. nothing crazy. We're just going to turn that LED on, but we're going to do it with a button. So we're not going to, that way we push the button, LED comes on. That's what we're going to do. But before that, just go over a few introductory parts that are key. They're the basics. So there's this thing called Ohm's law, which is, I'm not going to go into the physics behind Ohm's law. I will be here forever. I need a whiteboard to explain that to you. But basically, it's V equals IR, which is volts equals current times resistance. So voltage is just your power, basically. You know, you see it all the time, 9-volt batteries, probably what comes to my mind because that's what I see, but they're literally anything with power has some sort of voltage to it. It's just voltage is a unit of measurement. Then you have current, which is, think of like a river with water, of course, a flowing river, and the water moving is the flow. In electricity, it does the same thing, but the flow is called current, which could also applies to water. So it's what moves, what gets things working. It's why we have wires. Literally every wire has current going through it. Of course, how much depends on a lot of things, like what type of metal you use, what type of wire, how thick it is, what else is moving through it. And then resistance is basically what it sounds like. How much how much is it being stopped? How much is the current being blocked, in a sense? I don't know how else to explain resistance. So, in terms of power, what you would have, I just moved it somewhere. Battery. So this is what our main power source is going to be today. If I plug in this chip to the computer, then that would be our power source, but we're not going to do that today. We'll do that when we go into how to program an Arduino in a different show. But for today, we're just going to make it work. So we're going to use this for our power. Then in terms of resistance, there's different ways to go about resistance. There's usually two. Where's the other ones? Oh, these guys. So there are capacitors. They look different. There's a bunch of different ones. If you go online and look at what are capacitors, they look, let me see if I have other ones. There's also these little ones. I can't get them out because I have on nails. They're super tiny, little orange circles. What capacitors do basically is it kind of holds. They're almost like batteries in the sense that they can hold on to charge, but they really hold current and just keep it. And it's how when you unplug something, how it could kind of stay on for a second or two. That capacitor, if it has a capacitor and it's big enough, it's holding on to some of that power, some of that current, and slowly it depreciates over time. We're not going to use any capacitors for what we're doing today because there's no need. They come in handy with robotics, just with powering things. You don't want to overpower and blow things up. Let's see what else. And then we have resistors, which are here, and they're similar in the fact of they basically block your current. It's like if something was too hot, you put on oven mitts and you touched it. It's making that barrier. It's insulate. Well, it's not quite insulating, but it's in a sense kind of like an insulator. It's slowing down our current, lowering our power. There's all sorts of equations. There's a bajillion, literally, equations for calculating this. And also maybe when we do, probably when we solder stuff, I'll probably show a circuit, the actual schematic of it to show how things are drawn out. I don't have a thing to show you that today. And capacitors and resistors, they usually have, just like anything else, they have ratings, they have units of measurement. So for instance, these are all 10K. It's hard to see, but it's written at the bottom on the paper. These are 10K. Resistors have color codes. I would suggest just looking that up. I probably should have it memorized by now, but I definitely do not. They are complex, to say the least. Cool. And I think that's it in terms of that. So those are like basic parts. You know, you got wires everywhere. I usually use a different type of wire than these because these are not my favorite. Just to be honest. Um, Usually I'll either have a spool of wire and then I can cut and the length that I need and just do it that way, or I have a different whole like kit of wires and they come in different like sizes and colors. And they're a bit more, in my opinion, a bit more sturdy than these, but these are good for just like getting something done. Um, yeah, and then like I said, we have soldering iron. Solder is somewhere around here, and some tweezers. You might not. Oh, solder's right here. Tweezers. I usually don't use them too much unless something gets stuck where it does. Wire cutters, magnifying glass, um, safety goggles, and then this, which is also on the robot, that way back here, with the eyes. I just like using these honestly because they look like eyes. There's a bajillion ways, but these is a infrared sensor. Is this infrared? No, this is ultrasonic. Um, so just like bats, this is how I picture ultrasonic because this really works the same way. So just like with bats, how they make a noise and it bounces off something and it comes back to them, and that's how they see. That's how these operate. Is one side is the transmitter, one is the receiver. So one puts out like a signal, um, and once it bounces back, the other side picks up how long it took, and it'll run calculations, and you're able to get distance basically from that. I think if you look like on my Instagram, somewhere back in 2019, I posted a video, and I may post it if you join the Discord. I might post a video of how what it this looks like. But I did a project where I was trying to build a object avoidance robot, which is exactly what this is. But I was doing it with like 5 sensors. I forget why I was using 5 of these, but they're all connected. And then I programmed an Arduino to where I could graph visually see what it was looking at. So I could do like this. And on my screen, it would show the graph doing like ups and downs to see how like long it took. And using that, you can definitely do like a lot of calculations and say like, if it reaches 200, then turn this way, or if it reaches this, go this way. You can do a lot with that. It gets very intense. So now that we've covered all of that, we're just gonna go into making this circuit work real quick. Since we're getting close to time. So we're gonna use this Uno. Like I said, we're going to put power with our 9-volt battery. I believe these don't need 9 volts, seem like 5, but we're using 9. It's kind of the standard. I think most people who work with robotics just use 9 volts unless it specifically needs more. Like this one, forget how much power I actually needed, but I used a bunch of like AA batteries in order to power it since it has like circuits and motor drivers, and I need to make sure the ultrasonic got power as well as the wheels had enough power. Designing circuits and schematics is a lot. Maybe we'll do a session on that too. I use a software called E.V.E. Yes, E.V.E. And I'm sure there's others out there. That's just the one I originally learned. That one I used to do a lot of my schematics. So you can like, it's almost like Photoshop, but for making schematics. So you can like add different objects and connect lines. I believe you can even have it converted into what it would look like on a board. So you can like directly send the board specs to like a company and have them print it out. But that's a work in progress. Okay, so I'm going to use red and black for my power. Because that's just my standard, and it's really kind of the standard. Red is power, black is ground. Ground is basically how to describe ground. It's kind of like a dump in a sense. Um, most big like electrical places, they have their ground outside, literally in the ground, to do big stuff. For us, we don't need that. It's basically so that we can make sure that we have a full circle. When you're doing electronics, nothing works unless you have a full circle, like a closed system. Um, and so, in order for that to happen, we have power going in, something has to come back. So that's what ground is for, the purpose of completing the circle. So let's get red and black. I guess we can use the short ones. So I'm gonna connect the red cable to the power on here. Hard to see it, but along the sides, let's see if I can get it close. It's close. You can't really read it, but along the sides here, it tells you, and as well on the inside, along the side, it tells you what each point is. So there is one that says 5V on it, which is 5 volts. So that's what we're going to use and plug it into that. And then you can plug it into on this breadboard. There are different types of breadboards. I've got to go lower the light at some point. We'll make sure to do that next time we do a show. But along the side, oh, there we go, that'll work. So along this side and along this side, you see the red and blue line. So what happens is on this side and this side, they're all connected underneath this way. And then on the inside of it, everything is connected horizontally. So if I were to connect the red line to my red, you don't have to, but it makes sense to do it. So now that it's connected to this red line here, anything I put on this one red line will get power. So that makes it so that I can have more room. I don't have to have everything trying to plug into like just a few slots. I can use this entire line to get any power from. And then the same for ground, is plug it into ground. Cool. You guys are going to see me struggle when I move to the board because this board, for whatever reason, just doesn't like me. And so when I try to plug things in, like you'll see these resistors are all kind of bent all over the place from me trying to get them in there. It doesn't like to function with me today. Thanks for the follow. I'm gonna say come here. Yes. Is there an electronics robotics club at Make School? There is. It's a robotics club. I believe they're still doing the. I haven't joined it recently because distance and because life is crazy. I have so many things that I'm doing. I personally just am unable to schedule it, but do have a club, and I think that's actually what this came from. I have another one. I have another one of these robots that looks very identical, like very similar to this, and that's why I'm like, is this that one? I'm pretty sure it's the same, but this was something we were working on in robotics club like a year ago, and what we do in that club is basically this. We'll get a kit usually. You know, you can do robotics and make stuff from scratch, or you can buy kits online. They're sold everywhere. I'm probably going to build a kit on this show in a few weeks that I have in mind. So we buy a kit and we all work on it together. And it was really fun. Like we just hang out, drink juice, eat snacks, and just try to teach each other. Mind you, a lot of people are more code based. So it was like really easy for a lot of the people in the club to hop onto Arduino because it was similar to, it's kind of, I won't say it's similar to Python, but it's about the same difficulty level, at least in my opinion, to Python, if you've used that. And the hardest part was, and you know, the kits, they range. Like there's literally kits for all levels. Literally, I was on Amazon yesterday, good old Amazon, and there were like this kit is from Amazon. It's not, it's probably, I would say this is more of an intermediate level robot. There were ones that were like very beginner level where you just put like 3 pieces together and plug it in, and then you can start like coding with like drag and drop type things. There's what I tell people, and it depends on what people tell me they're interested. So like if they've never done robotics ever, or they're like I got started in middle school. Was it middle school? Middle school with something called Lego Mindstorms, which I highly suggest if you're like middle school or if you're high school, you've never touched it before. I would say do Lego Mindstorms. Even I would do it now if I felt like investing. But basically, it's like you get the microcontroller. Looks like an iPod, like a very very old iPod, like iPod, not iPod Touch, but iPod, and it's huge. And then the rest of the robot is basically like kind of Lego parts, and you can just plug it straight in, and it's like a drag and drop coding thing where you can just drag, like go forward 2 cycles, go backwards 3 cycles, that type of thing. So that one's very simple to get into. Then there's like Vex Robotics, which is not simple. That's definitely like intermediate / expert level. And then there are more expert robots. One of the one I want to buy, one of the kits, it's like this spider. It's kind of terrifying when you look at it, honestly. It's like this big, it's like this huge robot spider. But I really want to build it, and it's not an entry level project. And then you can also go to other places and find kits. So they're out there. Sometimes you can go to different places like Instructables. There's, I forget what it's called. If I remember the name, I'll post it in our Discord. But there's a place that is like it's almost like a social media, but for like makers, where everyone just kind of posts their projects, and you can find cool projects on there and do the whole thing. I'd have to remember what the name of it is and share it with you guys. I actually need to be on there myself. So in order to get this working, so now we have our power and our ground connected along the side here. And we need to, this LED here, we're going to use this a regular old LED. Light emitting diode is what that stands for. They're everywhere. Literally, a lot of things these days are powered by LEDs because they're very low power but high brightness. So, and they're little. It's hard to see them, but there is a positive and a negative side. The short side is the negative, and the long is positive. Yes, yes. And then also, if you look inside, you really probably won't be able to see this on this camera. If you look up a picture of the LED, you'll see inside there's like this slash, this like cut, and one piece is bigger than the other. The smaller piece is the positive side. So where do you go? I'm gonna plug this in. I'm just gonna put it, I'll call it in 2 different lanes. That's kind of hard to see, so I'm gonna put it in and then move it closer to the camera. So this is spread out. So that is in, see how close I can get this. Sun. Yeah, the sun is just so in the way today. But this is in 2 different rows. Let me see if I can do it that way. No. Freaking sun. This is in 2 of the different horizontal columns over here, so that we're able to, there we go. We'll figure this out one of these days. But it's in 2 different rows so that we're able to make a connection separately to the negative side and separately to the positive side. Make sure I pull that up so I can make sure I can see everything. Cool beans. All right, and then so we have some resistors here. We're going to use them. We don't really have to use them, but just to make sure that we don't like blow anything up. Not that we will, but I have definitely in the past overpowered some LEDs and they shattered. These ones, I think they're plastic, so I'm not too concerned with them. But just to be safe, we're gonna make sure we do that. So, and then we have our button here. Just a little push button type situation. And the goal is just that when I push it to have the light come on, the sun would set at this exact moment. Move that this way, so it's a little less sunny, but push button. So we need to make sure that we're getting a closed circuit. And in order for this button to turn on this LED, it has to be connected to the LED. So it can't be like in a separate system. We have to make a whole circle here. So what we're gonna do, I'm actually gonna disconnect the power cable. Not that it's connected to anything, but I usually don't have power connected until I'm like pretty certain that things are set up the way I need them to, just in case. But I'm just gonna imagine that it's plugged in and say that the red line on this breadboard is the actual power. So I want to make a connection from my power to my button. So because that is what is ultimately going to control it. I need the power to go from the board to the button, and then the button is going to go straight to the LED, and then the LED is going to go back to the board, basically. And the reason why, since power flows from the positive to the negative, so it's going to go from power to ground in this type circle. I need the button to be before the LED. So that's why the power is going to go to the button instead of the LED. Otherwise, the LED will turn on regardless because it's getting just straight power anyway. They need the button when it's up, it's not making the connection. And so the power will go to it, but then it'll stop. It won't go anywhere because the button's not pushed. The connection's still open. But when I push it, then it makes a connection. It closes the circle, closes the circuit, and then it's able to get the power to the LED. So I'm going to do that. I said I usually leave shorter jumpers than this. I don't like when my wires are everywhere. Wire management is a big thing. And if you get into robotics, electronics, I definitely say put a little time into learning wire management because it'll make your life easy. So now we have the power to the button. Then we're going to go from the button to the positive side of the LED. Make sure which side is positive. Okay, so I'm using a different color. It doesn't matter. As long as I just try to avoid using red and black unless I know I'm about to make a connection with power and ground. So we have this, and I'm gonna connect it to the positive side. It's gonna look weird because the positive side is on the opposite right now. Is what it is. So freaking sun. Something like that. So you can see that we have a red line. The sun, I'm in Arizona, and the sun is like on some other stuff today. I was like, now you want to come out. Anyway, so we have the power going to one side of the button, and then it jumps over and it goes to this wire, and then it's going to go to the LED. Okay, and then lastly, we're going to use a resistor for the LED to ground, just to like collect any extra current that may like flowing around. So I'm going to use a 220, wherever they are, real quick. I thought I had one out and put aside, but apparently not. I have these other ones. I'm not going to use the ones that are on there because I don't know what they are since I don't have my color code memorized. Yeah, 220. I think these are probably the most common, which is why I have like extreme long row of them versus everything else that's just like pretty small, basic. So let's rip this off. The love-hate that I have with resistors is profound because they never want to work. They're very malleable, like the wiring of them is very malleable. So it's hard to put them in. So we're going to connect it real quick. We're going to put the resistor. And I'm just going to throw it somewhere because I need this resistor to go to ground. It's not going to be the prettiest design that I've ever done, but it's going to work. As long as I can get it where it needed to go. Okay. And then make sure this one's fully connected. And this is why me and this breadboard have been fighting all day, because for whatever reason, it's very resistant to me putting things on it. All right. We have a resistor going from the LED, and I'm just going to put the resistor to ground. So I'm just going to use, I don't think I have any other black cables floating about. I do, but it's very long. Short. Yeah. So then just connect this resistor to ground. All right. So now we have a full circle. It's really hard to tell that it's a full circle because literally wires are literally everywhere. I'm gonna make sure get some curtains when we do this show. But I'm gonna connect this power back on. And so now the basic idea is the power's coming in from the battery, going through the red, up the red line, through this red cable to the button, then from the button through the green cable to the green LED. Then the LED is going to grab it and it's going to go through that, and that's how you get the light. And then it's going to go out through the resistor back to ground, back to the board, and then it circles back, and it just stays like that. So it's technically current is flowing, but it's stopping at the button right now because it's not pushed. So in theory, if I push this button, this LED should come on. In theory. Oh, yeah. I was so scared. I was like, please work. I was like, don't do this to me. So now, let's see if I can get it back here again so you see it. Boom. So what's happening is when I push it, like I said, it's making the full connection so that the circle can be complete. But if I let it go, then it turns back off. Now the thing about using the microcontroller, say I wanted this button to stay on, or if I click it once and then it stays on, and I click it again and it turns off, like a controller, a remote controller or something like that. To do stuff like that, I would have to program it and tell it, you know, if button press is true, let's say like I make a counter and say if I push it once, it turns it on. If I let it go, it turns it off. Something like that. I'd have to program it. But at a basic sense, this is what's going to happen. Regardless if you push the button, it's going to complete a circuit. I could just tell it not to turn off the LED. But in order to do that, I wouldn't have it set up this way because I'd have to have it connected to different parts on here, different ports, and program those ports to be like inputs and outputs and all sorts of things, and tell it, like, instead of the switch being directly connected to the LED, it instead would be connected to like a input. And that way I can say like, hey button, I want you to do this, and hey LED, I want you to do this, rather than them just controlling each other. That is a lot more in depth, and we will go into, we'll probably do this same circuit in the future, but we'll edit like different things that can happen based off the button press. We might even use like a 3-color, I have one, yeah, this guy, a tricolor LED. And that way I can program 3 different colors. So I can make like pinks and purples, so that I can adjust the red, green, and blue with the controller, all sorts of stuff. We'll probably do a similar circuit to this, only we'll use actual programming with the Arduino so we can control like more stuff. And that way we can just kind of be introduced to how it connects to the computer, the basic programming language, kind of how to get started. And there are built-in, I know there's one called Blink that you can just run anytime you start Arduino, so you plug it up just to like make sure it works. If Blink doesn't work when you plug in your Arduino, then it's broken, just to be honest with you. Because it'll blink this, there's like lights on here, and there's an LED on there that's on, and there's one that's blinking. If you tell that one built in to blink and it doesn't, then you have probably a bad board, and take it back. So let's see if there's any other questions in chat. So I don't think there's any questions in chat. So like I said, this is probably the gist of what we're going to do today, since we're already over time and it's kind of just the basic plan for today. As I said, we'll do some more shows for like robotics and electronics in the future. Definitely we'll make sure to either have both have my camera, me and my camera are gonna have a talk, and then to make sure like there's less natural light so that we can see what's happening on this board. So we'll probably do one on how to solder. So we'll use my soldering kit. I'll probably have some different proto boards, so I don't want to mess up the fancy one. I have different tips for different purposes for soldering iron, can change those out. Some helping hands to hold it. Might not need, well, no, we will. I'm gonna need that. And stuff like that. And then we'll do a different show on like the Arduino and how to program it. Like I said, I'll probably get a kit and just like make it on the show. Just sit here and build the robot. And then maybe the same with this guy, where once I figure out all the things that's messed up with him, then I will work on building him. I don't think most of this that needs to be done isn't building, other than the power system, is mostly programming. So when we get to that, we can work on programming him more than anything. Even name him. Someone give me a name for this guy. Like think about it. Like next time, tell me what his name is, because I like to name my robots, but they haven't been getting cool names lately because they annoy me. So I give them basic. Like my first robot was just called Walker because he walked, and so I need to come up with a name for him that's not like, I don't know, obstacle avoider. Yeah, so with that being said, like I said, follow me on Instagram, join our Discord, follow the channel, subscribe to like this Twitch, so that you can catch the show, see all the other stuff that we're going to build in the future. And then also you can reach out to me on any of those mediums and let me know like if you have something in mind that you want to see me build, or if there's something you've been trying to learn, maybe we can learn it together. Or just suggestions of like your favorite things that you've built or experiences you've had. Like should be Wally, not this guy. He's not deserving of that title, to be honest. I do have drawings. I don't think I have the book over here. Probably not. But I have with my inventions journal, and inside has sketches of different robots I want to build. And there is a robot in there that is very similar. Not very. He's basically a version of Wally. He just does something different. It requires a lot. So, Wally and E.V.E. Redbot. I might call him. Is he red enough to be called Redbot? Maybe I'll paint him. Maybe I'll paint the base down there because it's clear and he could be Redbot. Yes. So I definitely want to invite you all again to follow and subscribe on the Twitch. That way you don't miss any of our shows. Like I said, Brian has his TikTok pool. We're trying to get those numbers up there to the big numbers, and just spread the love of technology with everybody. Because I think it's fun. Like I could sit here all day and talk about this. We're just not going to do that today. There's other things to be coded. So we'd love to get as many people out there, build our tech community, share knowledge about what's happening in tech, cool new programs and libraries and frameworks to come out. Just sit here and sip tea. Maybe next time I'll bring tea. Well, no, I'm not gonna bring tea because I'm prone to knocking over fluids on my computer. I've done it 4 times. So there's a strict if no fluid in the zone. But proverbially we can imagine sipping tea together and building robots. So definitely subscribe and follow so that you can catch us next time. I will be here again next week, same day, same time, every Saturday. What we'll do next week, we will find out next week. Gonna roll with it. So I just want to thank you all again for being here, and make sure to come on to our Discord and join in the shenanigans over there. And otherwise, I will see you all next week. Bye.